Okay, we're going to do optimization problems today. And the plan is for this week, we're going to do this tomorrow. There is not much of a handout, and I'll get your quizzes back to you tomorrow. They're not quite done. Maybe if we finish early, I can work on them, but we didn't in the last class. Then Friday, we're going to do an evaluation of that little textbook we tried. I don't know. I've talked to the other teachers. We are going to grade it on the AP scale, though. So that helps. Yes? Okay, so that's the plan for this week. Okay? Now, optimization problems. These are max-min problems. Okay, Jack, put that away, please. In case you can play your games later. And that's the reason why a number of you don't know what's going on. Okay, you know, though, I would like you to do your homework, but if you just paid attention and really concentrated in class, you wouldn't have to do that much with the homework. Because when the max-min existence theorem, you're asked to state that, and you can't tell me what it says, what does the max-min existence theorem guarantee? A max and min. Oh, there were a number of people who could not tell me that. Seriously. So that means you're not really paying that much attention in class. I went over all that stuff. Two theorems we had. Extreme value theorem, we're going to use that a lot today, and the mean value theorem. And we did a problem like that, so I won't review that in this class. But so let's get into the optimization problems. Now, no, what they do is they might embed a small optimization problem within a big problem on the free response. Jack, put your phone away, please. You don't like the optimization problems? You did these last year. Do you need one? Yes, these are like related rates. But the good news is, if it is on the exam, they probably will give you the function, and you want to use the max-min existence theorem. Now, the other place it might occur, Casey, would be in the multiple choice section. Where are my scissors? Okay, it might occur in the multiple choice section. You know, it's 1 point as opposed to 9. So we worry about this, but we don't worry too much. Okay, Brian, put your phone away, please. I think I'll send the video to all the parents whose names of students I mentioned here. Okay. It really isn't that bad, but you do have to do the reading. And you're reading math, you got to read everything. Okay. A rectangular box is to be made from a piece of cardboard 24 inches long and 9 inches wide. I'm going to use a piece of paper. We're going to cut out identical squares from the 4 corners and turn up the sides. Now, you guys did this last year. I get to make the box. Yeah. And last year, you did the problem, but you didn't use any calculus. You found the function, and you then graphed it, right? You like doing these? You did the box problem, I know that. So we're going to fold up the sides. And there's the little box. I want to get the box with maximum volume because you're going to fill it up with popcorn. Or M&M's. Whatever. Okay. Well, let's get to work here. Now, it says start by drawing a picture, labeling the unknowns and the knowns. Okay, so I'm going to cut out the corners. What do you want to call the lengths that I cut out? Because I don't know what they are. X. So it's like related problems where you label the unknowns with some sort of variable. And then I'm going to label what I do know for a fact, that this long side is 24 inches, and the short side is 9 inches. And I want the dimensions of the box with the maximum volume. How do we find volume? Without the pencils. Length times width times height. So, if this whole side is 9, what's this little piece in here? 9 minus 2x. This to me is the hard part. What's the other side? 24 minus 2x. Good. So what's the volume? It's the height, which is x, times 9 minus 2x, and 24 minus 2x. Yeah, this isn't too bad. But what I'm going to do, well, last year you just graphed it, and you saw the max min. On the exam, if this is a calculator problem, you would not graph it. You could. It's not to say you couldn't graph it, but you will get no points if you don't show the calculus that goes with it. We're going to use the max min existence theorem, Brian. And that says I must have a continuous function. In the last class, I said, why do I have to know what the theorem says? Because you don't know if you can use the theorem. You have to know what it says. I have a continuous function, right? On a closed interval. Can I get a closed interval? Well, look at the picture. What has to be true about x? It's got to be greater than or equal to what? 0. What's got to be true about 24 minus 2x? It has to be greater than or equal to 0. Some of you will say, well, if it's 0, we don't have a volume. That's right. Remember, this is a mathematical equation trying to model the real world. So I can use the endpoints. And what's the other side? 9 minus 2x is greater than or equal to 0. This means x is going to be smaller than or equal to 12. This means that x is smaller than or equal to 9 halves, or 4.5. I must have the most restrictive domain possible. So that's 0 to where? 4.5. We want to close it. If we don't close the interval, then I have to use the first derivative test. I don't have a choice. Now, the max min existence theorem says that the maximums or minimums occur at the endpoints, put it away then, or where the derivative is 0. What's v of 0? 0 times 9 times 24. Another candidate is v of 9 halves. So it's 9 halves. 9 minus 2 times 9 halves, which is what? No. 9 minus 9 is 0. Sorry. So the volume when x is 0 is 0. The volume at 9 halves when x is 9 halves, which means that you're making this side really, really small. It's going to be 0. And if I have to have both a max and min, what does that tell you? Riley, what's that tell you? What's it? No graph. The function has to have a maximum somewhere. Where would that occur? What's it? The derivative. Some of you wrote down the function was 0 and undefined. No, the max mins occur where the derivative is. Jack, put that away. Pardon? It does, though. Right. Those are the places. These are all the candidates. Okay, so here's my volume equation. I'm rewriting it down here because I want to be able to work with it. Also, when you're doing your problems, be succinct about it. Some of you gave me long essays. When it's f prime is positive, you're done. You're done. That's all you have to say. whatever it is. In this case, we're going to find f prime, but before we can do that, I don't really think you want to use the product rule in that. You could. Well, why don't we just distribute it? So b is equal to x. Well, 9 times 24. See how big that is, Noah? Allison? If you do the problem with me, not watching, it's 216. Now, why do I know that? Because I just did it in the class before. It's the only reason. Minus. You should be able to do this one. Now, this might be in a calculator part of the exam. But even if it is and you graph it, that's fine, but you will get no points until you show the calculator. 48x, because it's happened, minus 18x plus 4x squared. And then I'll combine similar terms. What is that going to give me? 66, right? X plus 4x squared. I still could use the product rule, but I'd rather simplify because that's not hard to simplify. Alexi, what do I get? What's x times 216? 216x minus 66x squared plus 4x cubed. I'm just distributing my x's. That's a good question. If you see a step here, if you don't know how I got it, you got to ask me. Now, I still haven't done any calculus. I haven't done one bit of calculus except to know that theorem. That's about it. This is all algebra. This is everything you did in pre-calc. But now the calculus is to find the derivative. The derivative's not too bad, is it? This one's easy. What's b prime? Plus. Okay, I want where that's 0. Well, can I factor out anything bigger? I can do a 12. And the only reason I know that is because we did that in the other class. 12 times what gives me 216? That I don't remember. 216 divided by 12. It does. 18. And 12 into 132 is 11. That's the trick with the 11s. If I go 11 times 12, I do the 1 and the 2, and then I add the 1 and 2 and get 3. 11 times 13. I go 1 and 3, and then add these digits, 143. You haven't seen the 11 trick? On your fingers? Yeah. So it's 1 and 5 and check it. Okay, I'm going to erase that because it's in the way. That's what we should do Friday. You should bring in math tricks. Okay. Plus x squared. Well, honestly, I don't like to factor in this order. That's just me. I see it so much faster this way. It's because I've done it so often. Now, why can I factor so easily? Do you know how many trinomials, easy trinomials there are that can be factored? Okay, Casey? Do you know how many trinomials there are that can be easily factored? Not very many. And I've been doing this for 34 years. So I have seen them all and done them all multiple times. That's why factoring is easy for me. So it's x and x. Yep. And so the answers would be x is equal to 2 or x equals 9. Max-min existence theorem says that I have to look for these critical points and I evaluate the critical points and the endpoints in the function. 9's not in the domain, so we'll eliminate that. And you know why, though? Because this is a cubic function. What is the 9? The 9 is the minimum. So our domain only did that. Check. No, quadratic formula. Now, on the exam, let's say, hang on, I'll get your question. Let's say that let's say this function was a fifth degree function or something like that here. Okay, so then when you take the derivative, you're going to get a fourth degree. You have to use your graphing calculator to solve that. That's allowed because you're solving for zeros. And I think that's what happened. But what people did was they graphed this and came up with the answer. And they got no points for that. Sorry to say. Okay, your question. Okay. Because I looked at the box and said the sides had to be positive. This little piece I cut out's got to be greater than 0. I closed it because I wanted to use the mathematics. You're right. If I put in 0, I have no volume. Okay. And then I looked here at these. Because if you put in x is 5 here, 9 minus 2 times 5 doesn't work. Because that's 9 minus 10. You can't have a negative length. Because I can't have a negative length. So x is greater than 0, and x must be less than or equal to 9 halves. Yes, 4.5. Okay, so you guys, Jack, Brian, these are evaluated. We already did that, or didn't we? Yeah, we said there's 0. So what's the only place that this volume could have a maximum? At x equals 2. Now, did it ask for the volume? Yes. So I'm going to do v of 2. I'm going to do it right here because my function's right there. It's 2, and on the free response part of the exam, you wouldn't have to do anything with this. You could just leave the answer I've got here, but I know you're just dying to know what the volume is, right? Okay, Stephen, put that away, please. 9 minus 4 is what? 9 minus 4 is 5. 24 minus 4 is 20. So the maximum value is 200 cubic whatever. And the other problem with the graphing calculator is I have to have the right window to see where that is. I might not have guessed anything that big. Okay, Brian? That's how you do these problems. If you look at the last sheet, it gives you the steps. They're just like related rates. Okay, so let's do another problem. Are we ready? The volume is 200. Because it says, what is the volume? Volume equals 200. And all you have to do is evaluate. The only calculus is finding the critical point. That was it. Now, Brian, if you don't have a closed interval, then you have to do a first derivative test. So you have to find where the derivative is 0 or undefined, and then you have to do a little sign chart and tell me if the derivative changes from positive to negative or negative to positive. That's a lot more work. This is easier. It's not always easier, but most of the time it is. Till last year, when I was going over a problem, I said it was always easier. It wasn't in the domain. Because I'm guaranteed both a max and min, and the volume at the endpoints was 0. How can you get smaller than 0? Logic. Okay. Who has Di Lorenzo? You don't know who he is yet, do you? Oh, you do. I like to pick on him. He's an honorary math teacher. I don't think he knows any math. But anyway, when I was raising my family, lived on a farm, had horses. So this was a problem that was kind of important to me, especially this year with the drought. You want the biggest area you can have for your horses, and you want it all to be fenced. Now, if you miss a side or the fence breaks, then the horses get out, and then you have to chase the horses. It's not fun because they'll be sitting there like this, and you're right. You will literally be this close to grabbing them, and they just know. Minute you reach over to grab them, boom, they're off again. It took me 3 hours. I didn't even know 3 hours had passed before I finally caught the horses. They were tired of the game. I don't think I had. I might have had a bridle. I don't know. So That's a reason for doing this. And then they can be very dangerous, actually. Then I took my horses down to my cousin's farm, and she has horses, and horses like to battle over who's boss. Yeah, they will beat up on each other. So we put my horses over here, and her horses were over here. That didn't matter. About 2 hours later, they'd gone through the fence in between. My horses won, by the way. No, but they're the boss. That's all. Okay. So we're going to fence this. So Farmer Di Lorenzo, so you can call him that, has 10 meters of wire fence. And he wants to build two identical adjacent pens. And I says, what are the dimensions of the sides? I'm looking for X and Y, for which the area is a maximum. What is the area? Looking at your picture, it's length times width. So it's X times what? How many Y's? 2Y. Just like related rates, I have too many variables. You're going to take the derivative of A, but you don't want an X and Y in there. You've got to get rid of them. Now, numerically, this is not a very nice problem. But what we'll do is we'll label all these sides. That's X, and that's Y, and that's Y. And I need another relationship so I can eliminate X or Y. I mean, you know you have 10 meters of fence. So you have to fence this, all of this, and then this. So what is that? Y is not 10 minus X. What's the perimeter? There's 3 X's plus how many Y's? Or Y. Do you want to eliminate Y or X? Okay. So 10 equals 3X plus 4Y. And then we'll subtract 3X from both sides, and hopefully I won't make any mistakes. 10 minus 3X equals 4Y. And so I'm going to divide by 4. Now, while you don't have to reduce 10/4, it might be easier. I don't know if it is or isn't. So Y is equal to 5/2 minus 3/4 of X. So my area, this should be the hard part, is X times 2Y. So it's 2 times 5/2 minus 3/4 X. Just as I do in algebra class, I tell them to simplify as much as possible before they solve their linear equations. So I don't want to take a derivative here until I get it simple looking, and it's not simple looking at the moment. What happens when I distribute the 2 times 5/2? 5. This is going to look a lot better. And what happens when I distribute over here? No decimals, fractions. It's 6/4 or 3/2. That looks, to me, a lot better. Ask. I just distributed this. 2 times 5 says 10/2 is 5. Personally, I'd like to cancel. And 2 goes in once, 2 goes in twice here, so that's 3/2. Or 6/4. I'm still not done simplifying because I don't want to take the derivative of that. Still have to use the product rule. So it's 5X minus 3/2 of X squared. There you go. No calculus. Can we close the interval? We can. Okay? What's true about X and Y? I'm going to put it down here. What's true about X? It's the smallest it can be. 0. So X, you really should do greater than 0, but because we're going to use mathematics to model this, we're going to use the mathematics, Allison, and make it equal to 0. What's the other one that has to be greater than or equal to 0? Y. So Y must be greater than or equal to 0. So this function right here must be greater than or equal to 0. That's right. If it's 0, what do I get? 0. And then if I have 0 as one of my sides, then what's my area? 0. But if I have a continuous function on a closed interval, I guarantee a max and min Guess what? I just found the mins. Where's the max going to occur? Well, there's only one other choice, where the derivative is 0 or undefined. Now, it's not undefined, so clearly it's a polynomial. Do you agree that the area is going to equal 0? That a of 0 is going to give you 0? I don't know where that is, though. That's the other endpoint. Should we solve it? We can do that first. We still need to know this endpoint. Okay, so you guys want to do the derivative first. Doesn't matter. What's a prime? And I want where that's 0. So now, is it easy to turn this fraction upside down? Yes. Actually, I'd rather put the 3x on the other side. Adding 3x to both sides, 3x equals 5. So x equals 5 thirds. It's going to be, once I evaluate the end, find out where the other endpoint is, and I'm going to get 0 there, yeah, that will give me my maximum area. But I don't, if they don't ask for the maximum area, I can say, I know that's the maximum area because of the maximum existence theorem. Guarantees you will have both. So we need to find the other endpoint. So what I did before is I cleared out fractions. I still think that might be the easiest way to do it. I multiplied by 4. Doesn't change the inequality, does it? I don't like fractions. So 2 goes into 2 once, goes into 4 twice. So what do I get? Because I don't like fractions. I'm clearing them. You should have seen this before. So that's 10. And what happens to 4s? Minus 3x is greater than or equal to 0. So 10 would be greater than or equal to 3x. Divide by 3. I still don't have to reverse inequality. But to understand that inequality, I probably do. 10 thirds is greater than or equal to x, meaning x is less than or equal to 10 thirds. Yes, your domain is 0 to 10 thirds. So if you want me to draw a little chart here, I can. Here's x, here's a. We have the endpoints, 0 and 10 thirds. And then we have the other critical point where that's 5 thirds. You substitute them back into the area equation. I would probably go to this one. It's just easier to work with than the other one. So a equals 5 minus 3 halves x. I said that wrong. Okay, what's a of 0? That's easy. That's easy. That's 0. What's a of 10 thirds? Well, let's just do it. A of 10 thirds equals 10 thirds, 5 minus 3 halves of 10 thirds. What happens to the 3's? 2 goes into 10 how many times? That's 0. So that's 0. If they don't ask me for the area, I don't have to find the area at 5 thirds. I think they did, didn't they? So make sure you answer the question. So now I want a of 5 thirds, but I don't have to simplify it unless you really don't believe it's a maximum. Now, the other thing is there will be no tricks. If they ask you for a maximum, there will be a maximum. I've never seen them put a trick in there. They might say, um, show that there's no maximum. They might say something like that. But they'll give you a hint. They always give you a hint. So read for the hints that are in the problem. Whoops, forgot to put my 5 thirds in there. Sorry. Times 5 thirds. What happens to 3's? They cancel. And I don't really care if I simplify, but you probably want to know what it is. So it's 5 minus 5 halves. Why did I do what? I'm evaluating the area function at 5 thirds. That was when my derivative was 0. Because that's when my derivative was 0. Did I do that right? What's 5 take away 5 halves? 2.5 or 5/2. So what's the answer? No, not this. 6. Okay, this one was not very fun with the numbers. And honestly, big farm producers do worry about how to set up their fences with their animals to get the maximum area, especially this year with a very bad drought. Okay, one more problem. Ready? Oh, this one's actually easier. It's nice to end on an easy note. A lot easier. Now you should have a variety of these in there. Oh, look at that. Then I'll grade your quizzes. Okay, I have two non-negative numbers that add up to 10 and whose product is a maximum. What do you want to call the numbers? X and Y. So X equals the first number and Y equals the second number. And you know what? You're always going to get two equations in each one of these problems. I like to focus on what do I want to maximize or minimize, and there it is. What do you want to call the product? Because that's what you're going to take the derivative of. P. Good. And that's what? What's the product of my two numbers? X times Y. If I take my derivative now, then I'm going to have to use the product rule. I don't want both of those letters in there. But I know something. I know that these two numbers add up to 10. So what's true about X plus Y? Okay, which letter would you like to get rid of? The Y. So we'll subtract X. So Y equals 10 minus X. Some of you may have just go right to that statement. That's great. And some of you may be so happy because that's such a nice polynomial. Let's take the derivative now. Then we'll close the interval. Let's do that just for a change. But before I take the derivative, I need to multiply that out. Otherwise, I have to use the product rule, and I don't like that. I really don't. So P prime is equal to what? 10 minus 2x, and I want where that's 0. Or undefined, but it's obviously not undefined. By inspection, what's x? Because you get no points for showing the steps here. Alexi, what is x equal to? 5. Okay? Now, if I don't close the domain, then I'm going to have to do a first derivative test. And that's not always easy. It's easier just to evaluate my area at the endpoints and at 5. So I can make a little table, but I haven't figured out my endpoints. Now, there are two non-negative numbers. What's true about x? Greater than or equal to 0. How about y? Y must also be greater than or equal to 0. Here's my y. So 10 minus x must be greater than or equal to 0. What's my domain? You start at 0. That's usually the easy one. But go up to how big? 10. You can solve that inequality if you don't believe me. If you do 11, then y is going to be a negative 1. It said not negative. So if I open the domain up for everything, then I do have to worry about that. Okay, so here's my little table. And I want to find the product. Here's x, here's p. When x is, let's do the endpoints because those are the easy ones. Get as many points as you can. Do the easy ones first. When I substitute x equal to 0 in here, what do I get? I get 0. When I put 10 in over here, I get what? 0. That guarantees it now. Unless we have a flat line, a horizontal line, the next one has to be the max. So let's try 5 and see what the value is. So it's, no, I've solved to get 5. That's where the derivative is 0. Well, what's 5 times 10 minus 5? 25. And that's it. Because I want the product be a maximum, so we substitute it into the equation that we want to be a maximum value. You can try other values between 0 and 10. You'll find out that 5 is the biggest one. Because I took the derivative and I set the derivative equal to 0 and solved. I mean, this was kind of easy. I probably could have figured it was 5 before. 5 times 5 is 25. If I take 6, 6 times 4 is 24. It's smaller. I take 7. 7 times 3 is 21. Smaller yet. Okay? I knew that. You know what? 10 minus x squared looks like what? No, it's a parabola. It's upside down. Here's what it looks like without a graphing calculator. That's 0. That's 0. That's at 10. And guess where that is? Halfway between 0 and 10. Now, if this were the problem, you would get no points for doing the math in a different way, not involving calculus. Because you can. So I'm looking at it. I can see you can. So you have time to work on 4-4. There's not going to be a lot of emphasis. There will be, I think, one question on the test. 1 or 2. But there's not that much on the exam unless they strictly give you a function and say, find where the particle's furthest to the right or the left. If they ask for left, what are they asking for? Max or min? Minimum. Furthest to the left. You've had some problems like that. So I'll let you have time to do that, and then I'll work on, see if I can get these quizzes done in your class, please. That deal?